Let's look at a few of the functions that NLTK provides. Here are some functions that NLTK has to help you understand the context of a text. Concordance is a function that will display all the occurrences of a word in a piece of text along with some context. Similar, common context, and dispersion plot are other interesting functions that help you understand the occurrence of a word inside a piece of text. So for example, if you wanted to see what are all the contexts that the word very appears with inside a piece of text, then use the function concordance and it will print out all the occurrences of the word very in a text. Similar returns a list of words that appear in similar contexts. Now you would expect that these are usually synonyms, but sometimes you will see very interesting and unexpected results based on how authors use words in a text. Common context returns contexts which are shared by two words. Let's say very and much are used in a lot of the same context. What are the common contexts that are shared by those two words would be returned by common context. Dispersion plot prints a plot of all the occurrences of a word relative to the beginning of the text. You will see what we mean by this when we look at the examples that we code up. Here are a few functions that NLTK provides for processing text. Send_tokenize and word_tokenize, which, as the function names say, basically help with tokenizing text. Stopwords.words to filter out stop words. Bigrams, n-grams, and collocations. These help us in understanding commonly occurring phrases or groups of words. Now, send_tokenize and word_tokenize tokenize text into either lists of sentences or lists of words. Stopwords.words will generate a common list of stopwords as a list, which you can either convert into a set or keep as a list. Then you could always check whether a word is present in this list of words before you do any processing with it. That way you can filter out stopwords. Bigrams help you generate pairs of words for all the words which are present in a piece of text. So all possible pairs of words from the distinct words in a piece of text, or all possible groups of n words from the distinct words in a sentence or a piece of text. These are bigrams or n-grams. Now the most commonly occurring bigrams are called collocations, and you could find these by using the collocations function. Ideally, the collocations function should identify, for example, New York as a collocation because it understands that these two words commonly occur together. Let's take some examples to see how all of these functions work. First, let's import the NLTK module. To install the NLTK module, you can just run pip install NLTK or !pip install NLTK if you are doing it from the IPython notebook interface directly. To start, we'll need some text to play with, and NLTK itself has many corpora and resources for you to explore natural language with. So let's just download all of these. For this, a one-off run of one nltk.download will get you all of the resources in one go, but it will take some time. So run it, go have a cup of coffee and come back. Once you've run it and you've got all the resources and the repository of interesting texts, including things like Moby Dick and the inaugural address corpus, we can play with it and get some interesting insights. So here we're importing some books as text to play with using the nltk.book resource. Now these texts have been loaded and you can refer to them by their names. So text 1 is Moby Dick, text 2 is Sense and Sensibility, text 4 is the inaugural address corpus, which has all the inaugural addresses of presidents from, say, the 1800s till today. Now these are all objects of the class text. and they have a bunch of cool methods to explore the text. Concordance is one of those methods, which will print all the occurrences of a word along with some context, some words before and after it, wherever it occurs. So let's explore two separate texts, Moby Dick and Sense and Sensibility, and we'll look at the word monstrous and see how these two different texts use this particular word monstrous. So let's look at text 1, which is Moby Dick. Text 1 dot concordance of monstrous will return a bunch of occurrences of the word monstrous in the text Moby Dick. And it looks like Herman Melville uses this to mean terrifying or really big. Text 2 is Sense and Sensibility. Now, Austen is kind of different. She seems to use it to amplify a positive emotion. Monstrous glad, monstrous happy. So as you can see, Melville uses the word monstrous in a very different connotation than Austen. By the way, these examples are inspired by the NLTK book, which comes along with the NLTK documentation. You can see a lot of different cool examples and implementations of Python code for NLP in that book. Just go to www.nltk.org. So alright, it seems like Austen uses monstrous in a very different way. She uses it in a positive connotation. Let's see what other words she uses in the same context as monstrous. So see all these positive words, very, exceedingly, heartily, good. So she clearly uses monstrous to represent positive emotions and as an intensifier or an amplifier of those positive emotions. For example, instead of very, she uses monstrous, but with positive words like happy or glad. So let's see where Austen uses very and monstrous interchangeably. That is the context in which very and monstrous both appear. So she basically says be very glad and also be monstrous glad, or is very pretty and is monstrous pretty. So she uses monstrous and very as similar words or synonyms in these particular contexts. So these are just fun ways to explore the usage of natural language in different contexts or situations. Now let's see how the usage of certain words by presidents has changed over the years. This is a pretty cool example of how the usage of words has changed over a period of time. You'll have to install matplotlib before you run this line of code. Basically, we are using the dispersion plot method, and we're going to see how the usage of all these words, citizens, democracy, freedom, duties, and America, has changed over a period of time. Now, this dispersion plot method plots the occurrence of a word as relative to the beginning of the text. Now, the inaugural address corpus, we know, has the earlier president's inaugural addresses in the beginning and the later president's addresses later on in the text. So see how interesting that is? Looks like citizens is a word that almost all presidents from the beginning of time have used, but the later presidents seem to stress on freedom in America more and democracy as well. And the older presidents or the earlier presidents used to stress on duties a lot compared to the later presidents. Dispersion plots are fun and you can play with them. You can see, for example, which kind of emotions are expressed in Austen's works versus Herman Melville's. But let's get to some serious stuff now. Often you want to extract features from a text. So for example, you are performing a text classification and you want to represent a piece of text as feature vector. These are the attributes that will basically represent the text. These could be words or sentences or phrases that actually represent the text. So let's say we have to split a piece of text into constituent sentences or words. These constituent sentences or words are called tokens. So we'll use the NLTK.tokenize library, and we have two methods here, word_tokenize and send_tokenize. Let's take an example text. Mary had a little lamb, her fleece was white as snow. This has two sentences. So when you use send_tokenize, it basically returns a list having the two sentences. Word_tokenize will break a sentence or any large piece of text into words. So this particular piece of code that we wrote separated the sentences which we got in the first list into lists of words. Notice how we didn't explicitly write a for loop to iterate through the sentences in the list sense. We just wrote one line of code which broke up the sentences in the list. This particular syntax is an idiomatic way of writing code in Python and is very cool, and you should get used to it. Now let's filter out stop words. For example, our piece of text above has stop words like had, and as, which occur really often in the English language. So we'll import stop words from nltk.corpus and punctuation from the string library in Python, so that we can remove both punctuations like the period which was there in that particular piece of text, as well as these stop words. Let's create a set of all the stop words including the punctuation. Notice how we made it a set, because we don't really care about the order of the words in this particular set of stop words. If we cared about the order, we would have made it a list. Now we are using a similar syntax. We're saying words without stop words is the list of words where word is each word in word_tokenized text if the word is not there in the list of custom stop words. So see how all the stop words and punctuation marks were removed from our list of words. Now you can use bigrams, n-grams or collocations on a piece of text to basically generate pairs of words of all the distinct words that appear in a text, and also identify the most commonly appearing pairs of words. Here is a peculiar example which is something that you will commonly encounter. Now in this particular piece of text, close appears in different morphological forms, and you might want to just stem it so that all of them are treated the same, as the same word. So NLTK has different stemmers which are based on different rules or algorithms, and stemming is also known as lemmatization. So you might look for lemmatizers as well as stemmers. This is one particular stemmer, the Lancaster stemmer. Let's see how it stems the words. So the Lancaster stemmer has a method called stem, which will stem the words. We'll apply it on our sentence and see how all the forms of close were reduced to its based form. NLTK also has functionality to automatically tag words as nouns, verbs, conjunctions, different parts of speech. This is very simple. You can just use the NLTK_POS tag, which tags the words to their parts of speech and returns those tuples.